Missing data is a common issue in real-world datasets, and it can seriously impact the performance of your machine learning models. If not handled correctly, missing values can introduce bias, lower accuracy, and break certain algorithms entirely, as lots of machine learning algorithms do not support data with missing values. For example, if a medical dataset is missing patient information, a disease prediction model might misclassify sick patients as healthy simply because the model didn't have enough data to make an accurate prediction. Furthermore, many machine learning algorithms, like linear regression, support vector machines, and deep learning models do not support missing values natively and will throw errors unless the data is pre-processed. In this video, we will focus on how we can detect missing values in Python, and in future videos, we'll learn how to deal with missing data. Before we dive into finding missing data, let's ask the big question. Why does data go missing in the first place? Here are some of the most common reasons. First, there is a human error. Maybe someone forgot to fill in a field, or maybe the intern hit enter too soon, or maybe the survey respondent just didn't feel like answering how many cats they own. This will lead to missing data. Also, there are system glitches. As data pipelines break, sensor fails, or files get corrupted, leading to the manifestation of missing data. And there is also manual data removal, as data might have been deleted on purpose, either to clean noise, or more likely, someone somewhere thought, meh, we don't need that.
Correction.
You don't know that!
I'm the only one who knows that.
So, how is missing data represented in Python? Let's create a sample data frame containing some missing data. In Python's pandas library, missing data is typically represented as the NumPy none type for numerical columns. None means not a number. They are also encoded as none for object or string columns. So, how to identify missing data in pandas? You can check for missing values using the .isNull function. This will return a Boolean data frame where true indicates a missing value in that position. You can also count missing values per column using the .sum method along with axis equals 0. You can do the same thing and count missing values but per row using the .sum method but specifying axis equal to 1. And this will return the number of missing values for each row. To get a quick overview of the total missing values in the entire data frame, simply sum twice. This will return the total number of missing values within your data frame. You can as well use the .info method for a quick summary. This gives an overview of the non-null counts per column. Sometimes missing data is hidden using placeholder values such as -999, NA, or unknown, or really anything else. These won't be detected by the isNull method unless you convert them. You need to read the metadata carefully or investigate within your data frame to see if missing values are encoded using a given placeholder. Once this is identified, you can replace these values manually using the df.replace method. For example, if nones are encoded as -999, you can replace them this way. You can use df.replace -999 to pd.na and specify in place to be true. Note that in the above function, we fixed in place to be true as the default is in place equal false. This means that operations return a new data frame without modifying the original. To apply changes directly to the original data frame, use in-place equal true. If you don't want to do that, you can reassign again to your data frame to apply the modifications. To understand missing patterns visually, we can use the Missing Now library. First, make sure to install it via pip and import it. We can use the msnow.matrix to generate the following missing data plot. White lines in the plot indicate missing values. The bar on the right shows the number of the non-missing entries per row. This visualization helps detect if entire rows or columns are incomplete.